So let's take a look at solving linear inequalities. We're going to solve linear inequalities the same way we would solve a linear equation. So whatever steps you would have taken if it had an equal sign, those are the same steps we're going to take when it has a less than or equal to, greater than or equal to. There's one difference, one major difference, and that's when we multiply or divide by a negative, we must flip the direction of the inequality sign. When we multiply or divide by a negative, we must flip the direction of the inequality sign. And so to give you a quick understanding as to why that must occur, if we start off with 2 less than 3, and so we know 2 is less than 3. If I multiply this 2 by a negative 1, I will also multiply the 3 by a negative 1, because what I do to one side, I have to do to the other. Once I multiply both sides by a negative 1, I would get a negative 2 and a negative 3. The only way to keep this true is to change the direction, because negative 2 is the one that's bigger than negative 3. Now here I said I multiply it by negative 1. The same thing would happen if I divided by a negative 1. The 2 would become a negative 2, the 3 would become a negative 3. So the only way to keep a true statement is to flip the direction of the inequality whenever we're multiplying or dividing by a negative number. So let's take a look at a couple of quick examples. Our first example, we have 5, 6x greater than or equal to negative 8. If I want to solve this, I have to divide by the coefficient of the x, the 5, 6. The only thing on this side of the equal sign, of the inequality with the x is that 5, 6 is being multiplied by the x, so I have to get rid of it by dividing by it. I divided by a positive 5, 6. So nothing changes. I divided by a positive 5, 6. So nothing changes in terms of the direction of the inequality. And so 5, 6 divided by 5, 6, that's just a 1. So I'm not going to write 1x, I'm just going to write x. But now I have to figure out that negative 8 divided by the 5, 6. If I'm dividing, I change that to a multiplication, and then I use the reciprocal. So I flip that bottom number and switch it to a 6 over 5. Now I can multiply the negative 8 times the 6 to get a negative 48. And then that invisible 1 times 5 to get a 5. 48 over 5 is already simplified. So that's where I would stop. If I need to write my answer as a mixed number, so if the directions on the problem says to write the answer as a mixed number, then I take and divide the 5 into the 48 to get a 9. So I'll have a negative 9 wholes, and the remainder will be 3, so it'll be 3/5, so negative 9 and 3/5. But most of the time, the improper fraction is what we're looking for, so I'm going to leave my answer like that. If I need to finish this off by getting the answer in interval notation, here it says that my x is bigger than my negative 48 over 48 fifths. So I'm going to mark the negative 48 over 5 on the number line. It says x is bigger. The bigger side is to the right, so I shade to the right. Now it has an or equal to, so I'm going to use a hard bracket. Whenever it has the or equal to, I use a bracket. And see, I'm highlighting the equal to part in the bracket. So that's the graph of the solution. That's the graph of the solution. Now, sometimes in textbooks, they'll tell you instead of using that bracket to use a closed circle. But I'm going to use the bracket because we're working on our interval notation. Now I'm going to make my interval notation match my graph. I have a bracket on the negative 48/5. That's where I start my shading as I read from left to right. And where I stop my shading is on the far right. So comma, and I'm stopping on the far right, and we write that as positive infinity. That means to keep going and don't stop. To the right. For my infinity, I can never equal the infinity, so I'll use a parentheses. I can never equal the infinity, so I use a parentheses. And that's the interval notation that we would have to mark for our answer. Let's take a look at the next example. We have 6 times, in parentheses, 2 minus x, greater than or equal to 12. So if this didn't have an inequality, I would just distribute my 6. So I'm going to do the same thing. 6 times 2 is 12. And 6 times a negative x is a negative 6x. That's greater than or equal to 12. Now, if I want the x by itself, first thing I would move is the plus 12, that positive 12. That's on the same side as the inequality, as that negative 6x. It's a plus 12, so I'm going to use a minus 12 to move it. 12 minus 12, if I'm doing it on one side, I have to do it on the other. So here's the minus 12, here's the minus 12. So I have it on both sides. 12 minus 12 is 0, and that's what I have on the other side. So I have negative 6x is greater than or equal to 0. From here, I need to get the x by itself, so I'm going to divide by the negative 6. So I'm writing this step over so I can easily just flip my inequality the minute I know that I'm dividing by the negative. A lot of times students will not write a separate line for this. They'll use the line up here. If you're using this line, this negative 6x greater than or equal to 0, and then you're immediately starting to do the divide by a negative 6, you will still have the greater than or equal to on your paper. And so when you write divide by negative 6, a lot of times students say, oh yeah, that's right, I have to change my inequality. The minute that comes to your mind, you need to write it on the paper. If you don't write it on the paper, circle it. Give yourself some kind of indication that you have to do something extra, or do it. And so we'll say, oh yeah, I have to flip my inequality. And then when we go to write the next line, we forget to flip the inequality. So immediately write it on the paper, or circle it, or do something to remind yourself that that's what you have to do. So then on that left side, we'll just get an x, and 0 divided by anything is 0. So if I need the solution graph, I'm marking my 0. This time I'm saying x is less than 0. That means x is smaller than 0. We find the smaller than on the left. It says or equal to, so I'm going to make certain I have the bracket which has the or equal to in it. That would be our solution graph. And if we needed our answer in interval notation, this time we're starting our shading on the far left. We write the far left as negative infinity. And negative infinity is something that we cannot equal. It's something tiny, 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 and we can't even give you a number for it. So we just call it negative infinity. We can never equal that. My shading stops at the 0, and we have a bracket on the 0 because we said we can equal the 0. Let's do one more example. So this third example, we have 3x plus 9 is less than 5 times the parentheses or the quantity x minus 1. So on this one, my right side of my inequality is not simplified. I need to clean that up. I will have to distribute. So I'm going to copy down my left side. 3x plus 9 less than. I'm going to distribute the 5. 5 times x is 5x. 5 times negative 1 is negative 5. Now I have both sides of the inequality cleaned up. Now I need to get my x's together. I cannot solve it while my x's are on two separate sides. So I have to pick an x to move. Some of you have the habit of automatically taking the x's that are on the right and moving them to the left. Some of you have the habit of automatically taking the smaller one and moving it. Either one works. And so I'm going to show you both of them. So first I'm going to show you the one where I take the 5x and move it to the left. So it's a positive 5x. I move it by subtracting 5x. And if I do it on one side, I have to do it on the other. And so the part that I've underlined is the part where I'm moving it. I wrote it on one side and I wrote it on the other. 3x minus 5x gives me a negative 2x. And then I can copy down my plus 9. And then the 5x minus 5x is 0, so I don't need that. So I'm copying down my less than sign, and I'm copying down that negative 5. That's at the end on that right side. From there, I have my x's together. Now I can subtract that 9 to get rid of that plus 9. And if I do it on one side, I have to do it on the other side. So that will leave me with a negative 2x less than, and negative 5 minus 9 is a negative 14. To finish this problem off, I have to divide by negative 2. I'm dividing by a negative, so automatically I know I'm going to have to flip my inequality. Multiply or divide both sides of the inequality by a negative. You flip the direction of the inequality. So I have x is greater than 7. Negative 14 divided by negative 2 is 7. X greater than 7 means that I want to be bigger than 7. My x is bigger than 7. Bigger than 7 is on the right of the 7. It doesn't have the or equal to, so I can't use the bracket that has the equal to sign hiding in it. So I have to use the parentheses. And to write this in interval notation, I'm going to start at the 7 with the parentheses, and I'm going to the far right. So I'm going to infinity. Infinity has a parentheses. If you're in the habit where you always move the small one, instead of moving the 5x, you would be moving the 3x. So you would subtract 3x from both sides. And again, I'm underlining the part that I'm doing to both sides. So I have a minus 3x on both sides. So 3x minus 3x is 0. That leaves me with 9. Less than 5x minus 3x is 2x. and then I copy down the minus 5 or subtract 5. Now I'm still trying to get x by itself. First, I just had to get my x's together. So now I need to move that minus 5 by adding 5. So I'm going to add 5 to both sides. Nine plus 5 gives me a 14. So I have 14 is less than 2x. Now I'm dividing both sides by 2 so that I can get my x by itself. It's a positive 2, so I don't have to flip the inequality. And I get 7 is less than x. That answer is the same thing as that x is greater than 7. They're the exact same. If you look at it, you're saying that 7 is the smaller one. When you say x is greater than 7, you're saying 7 is the smaller one. When you say 7 less than x, you're saying 7 is the smaller one. And so they're the exact same. If you have to have that x written up front, when you switch the size of the inequality, wherever that inequality points, it has to stay pointing. So here where you have the 7, that's where it's pointing, and it's opened up and eating the x. So I'm going to keep it opened up and eating the x and pointing to the 7. And that's how I write it to where I can see that it is the same thing that as what we had before. And again, to get my answer for the graph, if I was looking at the one that said 7 is less than x, when you're telling me 7 is less than x, you're still telling me x is bigger than the 7. So when I mark my 7, I'm still going to go to the side that's bigger than it. So I'm still going to get this. Whether I rewrite the inequality or not, I'm going to get that, which means I'm still going to get this for my interval notation. Same answer. And that is our linear inequalities.